Homework 16, Exponential and Logarithmic Equations, Video 5. Logarithmic Equations, logs equal to a number, Part 1. As I mentioned before, there were two types of exponential equations and two types of logarithmic equations. The first type is where you have a bunch of logs equal to a number. And when I say a bunch, it might just be one, like this one. So I'm going to go ahead and set up the steps. But I'm intentionally leaving step 1 blank because I know that it's not going to be illustrated in this example. I will complete it in the next video. Well, let's say you want to solve log base 3 of x squared plus 2 is equal to 3. My goal is to get the x by itself, or whatever the variable is, as is the goal of any solved equation. But where is the x currently trapped? Inside the log. So we need to get it out of there. How can we do that? Again, this will be step 2. Step 1 will be filled in the next video. We can get the x out of the log by rewriting the equation. Rewrite the equation in exponential form. In the previous series of videos, actually it was 2 series of videos ago, one of the videos was about going back and forth between exponential and logarithmic form. So this one is already in logarithmic form. Let's rewrite it in exponential form. Now remember, the way to do that is to remember what the answer to a logarithm means. The answer to a log is the power that turns the base into the argument. So the answer to this log is a power that turns the base into the argument. Base, argument, power. Base, argument, power. That frees the variable from inside the log. So your third step is to finish solving. Now there's a fourth step on this one. It's kind of necessary, although it won't seem necessary in this one. We should probably figure out that 3 to the third power is 27. This is just a quadratic equation, and we have ways of solving it. But it only has one x term, which means we can solve it using square roots. Subtract 2 from both sides to get 25 equals x squared. That's convenient. Square root both sides, and don't forget that when you square root both sides of an equation, you have to use a plus minus. So x is equal to plus or minus 5. Which looks like we're done, but the fourth step is to check for extraneous solutions. Extraneous. I'm not sure if I've used that word before. I think I did when we talked about solving radical equations. But you check for extraneous solutions. Now what does that mean in this context? Our equations have logs, and we can't log negative numbers. So another way of saying this is we need to discard, quote, solutions, unquote, that create negative arguments. Discard solutions that create negative arguments. You know, outside of the context of math, that can mean something completely different, but we'll leave it be. So if I plug these in, let's see what happens. And we'll just do this verbally. If I put 5 here, 5 squared is 25. 25 plus 2 is 27. That's not negative. If I substitute negative 5 squared is 25, plus 2 is 27. That's not negative either. So both of these are okay. But there will be some problems where you'll get a solution that you need to throw away because it causes an argument to become negative. All right, so just in a nutshell, if you have a log equal to a number, you can rewrite it in exponential form, finish solving, and then check your solutions. In the next video, we'll take a look at an example that not only illustrates the first step, but why the fourth step is necessary.